This video is on how to expand a perfect square. So two important questions to ask will be, what does a perfect square expansion look like? And then the other important question is, why is it called a perfect square? If you understand why it's called a perfect square, then I think it's much easier to recognize one when you see it. So perfect square expansion, if we think about where perfect squares come from before we even look at algebraic expressions, when we think about a square number, that's just the result of taking a number and squaring it. So something like 36, 9 squared is 81, 2 squared is 4. These are all square numbers. Now if I take an algebraic expression, say for example 2a, and I square it, I get 4a squared. And sometimes you'll hear that referred to as a square term or as a perfect square. So a perfect square consists of any bracket or algebraic expression raised to the power of 2. The square comes obviously from the 2, so that's a big hint there. And usually in Year 9, the expressions we're looking at are binomial. So something like m minus 4 all squared is a perfect square. And we're going to learn how to expand that. When in terms of why is it called a perfect square, well, if I take any number, if I take that expression, and I go and substitute a number in, let's let m equal 10, then I'm going to get 10 minus 4 all squared, and that will give me 6 squared, which is 36. So whenever I substitute values into a perfect square expression, then I will get square terms. So if I picked another number, like let's pick 3. Let's put in 3. I'm going to change my 10 now to a 3. 3 minus 4 is minus 1, and minus 1 squared is 1, which is again a square number. Okay, so a perfect square expansion will generate perfect squares. So you can see where this word or where this name perfect square comes from. So how are we going to expand a perfect square? Well, to come up with the quick method, it makes more sense to do FOIL. So if I was to use FOIL first, which is not the way we're going to do it in the end, let's expand it. Now when it says squared, it means multiplying the bracket by itself. So I'm going to use FOIL by writing out that bracket twice. And I'm going to multiply the first term. I'm going to multiply the outsides, that's minus 4m. And I'm going to multiply the insides. And what I want you to notice, it's different to a difference of two squares. With the difference of two squares, those two terms here, these two terms, that one and that one, they were opposite in sign. But this time round, I don't have a plus and a minus. I have a minus and a minus. And what does that do? Well, it gives me the exact same term. Two lots of the same term. And then I'm going to multiply, lastly, the last term. So minus 4 times minus 4, that's positive 16. So what I'm getting is you can see the similarity between the difference of two squares. We can square the first term, and we can square the last term. But instead of the two middle terms cancelling, we end up with 2 of them. So we get minus 8m plus 16. So the most common error with expanding a perfect square is when students will square the first term, and then they'll square the last term, and then they will think that they are done. Okay, that is wrong. I want you to stop from doing that sort of right now, because we can see straight away, if we look at the expansion I just did for you, there are 2 terms. There are 4 terms, firstly, when you expand it, and the 2 terms in the middle are the same terms, so they will not cancel. So you should be expecting to get 3 terms in your perfect square expansion. Sometimes you will see it written as a rule where it says, well, if the perfect square expansion looks like this, then we can square the first term. Now, remember what I said before, we end up with, actually, let's look at it. Let's do it the long way. If I have a plus b all squared, that's going to be a plus b, and then another a plus b multiplied together. So we're going to do the firsts, then we're going to do the outsides, that's ab, and we're going to do the insides, that's ab again, or ba, but ab and ba are the same term, so I'll write down ab. And b times b is b squared. So I want you to notice once again that I did get that term being repeated. Now how will I turn this into a quick little rule? Well, I will square the first term, I will square the last term, and then this is the hardest part. You will multiply the terms inside the bracket, see the A and the B, multiply those two together, and then you will double it, because there are 1, 2 of those terms. Okay, they will happen twice, and that's why we do this doubling here. But using FOIL to expand a perfect square is not necessary anymore. We now have a nice little rule. It's where we square the first term, square the last term, and we times the two terms in the bracket together and then double the result. So once again, you should be getting 1, 2, 3 terms in your answer. Do not just square the first term and then square the last term and think you're done. Big reminder, we want 3 terms. So the quick rule would be, some people like to see it algebraically, some people like it in words, a squared plus 2ab plus b squared. So let's do that. Let's square the first term. So here I've got n plus 4 all squared. You can see they all look like perfect squares. A bracket to the power of 2, a bracket to the power of 2, a bracket to the power of 2. So square the first term. Now we are going to, this is the hard bit, times them together. That's 4n, and double 4n is 8n. And then I'm going to square the last term, which is 16. Done. Fairly quick. Square the first term. Now, when I times these together, don't forget there's a negative. This was easier because both the terms were positive. But if we multiply them and one term's a negative, well, that's minus 11y. And doubling, when people double, they think the negative goes away. But we're really just timesing by 2 by doubling. So we're going to get minus 22y. So if you have a negative here, your middle term will be negative. And then square the last, positive 121. Please remember, when you square a negative number, it is always positive. So this sign here has to have a positive. All right, lucky last. Square the first term. That's 9x squared. Multiply these together. That's minus 15x. And when I double it, I'm going to times by 2. That'll give me minus 30x. And then I'm going to square the last term. Don't forget, if you square a negative, you have to get a positive. And 5 squared is 25. Okay. How many terms did I get? I got 3 terms here. How many terms did I get here? 3 terms here. How many terms did I get here? 3 terms here. So we really want to avoid, I hope that nobody who watches this video tells me that if I have c minus 7 all squared, that it is equal to c squared plus 49. That is a common mistake that teachers will see all the way through to year 11 and 12. No, 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 no. Okay, we're supposed to be getting 3 terms. We're supposed to be squaring the first term, timesing these together, that's minus 7c, and doubling is minus 14c plus the 49. So it seems like this is the problem for students. So let's make sure that that is fully understood by the end of this video.